In this video, Chapter 2, Section 4, we're going to talk about parent functions. And so we're going to be graphing a lot this year, and every graph sort of has its basic parent function, and you want to really master the parent functions. You want to understand the shape of them, because then once you know what they look like, then you easily know how to shift it when we get to the transformations, up, down, left, or right, vertical stretches and compressions and things like that, and it'll be very, very simple once you know the basic shape. So in this drawing, we have our basic functions. We have our absolute value function first, and if you notice, the absolute value function is in the shape of a V, okay? Let's show you how that kind of comes about, right? So let's think of, remember that y is just a fancy name for f of x, right? So if x is 0, I know the absolute value of 0 is 0. If x is 1, the absolute value of 1 is 1. If x is 2, the absolute value of 2 is 2. If x is -1, the absolute value is +1. And if x is -2, the absolute value of -2 is 2. So if I go to graph that, let's just kind of do 2, 2, right? Let's do 2, 2, right? 1, 1, 0, 0, -1, +1, and -2, +2. And you see where the V comes about. Your domain in this, remember that your domain is always all real numbers unless x is in a denominator or in a radical. So your domain is going to be -infinity to +infinity. And your range, notice that if you go from bottom up, you see that your lowest point is 0, and then it goes to +infinity. We're not going to worry about these today. Okay, and so again, absolute value bar, V-shaped. We go to a square root function, and again, you have to kind of think about, how you would graph it or whatever, and so again, we're just going to kind of think about what values we would plug in here. Remember that inside the radical, we cannot have a negative number, remember? So our domain is going to be probably restricted here, so we're going to start with 0. And the square root of 0 is 0. We'll start with 1, the square root of 1 is 1. And then we jump to 4, for example, and the square root of 4 is 2. And so we start with 0, 0, and then we do maybe 1, whoops, it's not 1, 1, it's a terrible graph. Let's do 1, 1, like kind of like that, maybe 1, 1, something like that. It's here, and then 2, 3, 4, and it would be about 4, 2. And you notice the curve, and it goes like that, and so it will go to infinity that way. But the basic square root function graph looks like this half curve here. And so my domain here, again, when there's a square root, my domain is a little bit limited, right? Notice my x value, my first x value is going to start at 0, and it's going to go to +infinity. And my range, if I go bottom up, is also going to start at 0, and it's going to go to +infinity as well. Obviously, my domain is from this 0 to this +infinity. My range is from 0, the y part of 0, up to +infinity that way. But again, that's the basic shape of that graph. When I go to my quadratic function, that's going to be, again, we're going to think of some x's and input and outputs that we can get if I ask you to graph this. And again, think of 0. Okay, if I plug 0 in for x, my output is 0. If I plug in 1 for x, my output is 1. If I plug in 2, 2 squared is 4. And if I do -1, -1 squared is 1, and -2 squared is +4. So notice I have 0, 0, I have 1, 1, I have -1, 1, and I have 2, 4, something like that, and I have 2, 4. So at first you think it might be more like an absolute value graph, but you notice that it's not 1 to 1 like this, like 1, 1, 2, 2, 0, 0. It kind of goes up a little quicker, and then you notice that it has a curve to it. And so again, that is your basic parabola. It's symmetric to the y-axis. It's an even function. And again, my domain here, my x values go from negative infinity to positive infinity, so it's all real numbers. Again, remember, your domain is always all real numbers unless there's a radical or a denominator of x. My range is a little different. My range is going to start at 0 and it's going to go to positive infinity. Okay. Again, we keep going. We're going to go to our cubic function. Our basic cubic function, it's like a squiggly line. You know, it goes like here, it goes up like that, and then it kind of goes down like that. And again, how does that look? Well, if I was to ask you to plot it and graph it, think of the numbers you might use, right? You might say 0 squared is 0, or 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. Or negative 1 cubed is negative 1, and negative 2 cubed is negative 8. And so when you go to graph this, you notice again 0, 0, you're at 1, 1, you're at negative 1, negative 1, something like that, right? And then you go from 2, and all of a sudden it jumps. 2 goes to 2, 3, 4, 5, 6, 7, 8, and it's way up here. Okay, that's 2, 8. And then to negative 8 would be way down here, and that's where you get it. So your domain is all real numbers. It's negative infinity to positive infinity, and your range is actually all real numbers as well. Now the difference obviously is your domain is going to increase slowly. You know, you're going to go to 3, 4, whatever. Your range shoots up very quickly. But again, it's still negative infinity to positive infinity. And then a cube root function, that one's kind of interesting. Well, again, we'll try to figure out what numbers would I plug in if I asked you to graph it. You'd start maybe with 0. The cube root of 0 is 0. You go to 1. The cube root of 1 is 1. You go to 8. The cube root of 8 is 2. And again, you can do negatives with cube root. So negative 8 is negative 2. And so you start out again and you get 0, 0. You get 1, 1. 2, 3, 4, 5, 6, 7, 8, and you get to like here, and you realize that you've got another squiggly, but this one is side to side like that, negative 1, and then you come over here to negative 8 and 2 or whatever. And so again, that's the basic shape. Your domain here, again, is going to be, it's in a radical, but notice it's a cube root. You have no restrictions. You can have a negative inside of a radical as long as the root is going to be an odd root, right? So this is going to be all real numbers, as is the range, okay? And so again, these are your basic parent functions. You definitely want to learn these, okay? You want to know when you see a quadratic, function, you want to think parabola, okay? When you think of a cubic function, you want to think of this squiggly line, okay? When you think of a cube root function, again, you want to think of, notice the square root function up here, okay, is like half. The cube root is sort of like that half, but it has the other side, okay? So again, cube root and square root go the sideways parts, but they are a little bit different. And then again, our absolute value, okay? So these are the basic ones. You definitely want to work on memorizing and mastering what these look like and how to graph these, okay? Read all this, okay? So then now we're going to work on graphing piecewise functions, and these are a little bit challenging. I sort of do them a little bit differently, I think, than a lot of people. I sort of try to identify in my piecewise function where my area of interest is. In other words, if you notice, it's kind of broken up into two sides of my graph. There's one graph is going to be the graph of 2x plus 3, and that's when x is less than or equal to 1. And the other one is going to be the graph of negative x plus 4 when x is greater than 1. And I sort of like to come here, and I sort of like to draw that little border. I know everything to the left of this yellow line is going to look one way, and everything to the right of it's going to look another. I noticed that all these graphs here on this page, they're all linear, okay, because they're all x to the first power, okay? So that makes my graph easy. I'm just basically graphing lines, okay? So let's start with the first line. Because 1 is kind of my critical area, I know that I'm going to have points on one. One point is going to be a closed circle and one's going to be an open circle. There won't be an overlap in these. I know this will be a closed circle at 1 and this will be an open circle. So when I'm working with the equation 2x plus 3, okay, if x is 1, I know my output is 5. So 1, 5 is one ordered pair. If x is, and this is all about x is less than or equal to 1. So let's try 0. And again, if x is 0, then it's 3. So 0, 3. So I know, again, closed circle at 1, if x is 1, y is 5. And if x is 0, y is 3. And so I can, and through any 2 points is a straight line. So I can already draw that line from there. Now I'm going to come and draw the other side. I know, again, negative x plus 4 is the equation, and it says if x is greater than 1. So I'm going to make x 1, and I know that's going to equal 3. And I'm going to make x 3. So negative 3 plus 4 is going to equal 1. So the ordered pair that goes with this is if x is 1, right? If x is 1, the output is 3, and if x is 3, the output is 1. Sorry, 1. So if x is 1, the output is 3, open circle. If x is 3, the output is 1, closed circle. And again, through any 2 points is a line, and there's my piecewise function. And so like I said, I just like to differentiate where the open circles are, and I like to differentiate my critical piece. So again, I come over to the next one, and I see that this is talking about when x is less than or equal to negative 4, or when x is greater than negative 4. So I know that negative 4 is going to be kind of like that critical line in my drawing, right? It's not like a line that I'm of the graph, but it's like my little border area. Let me just kind of do it in this little shaded thing. Okay, and so again, I'm going to plot a couple of points. I can do it on a table of values if I prefer. It's up to you how you do it. I could do, f of, let me do it in red. The top one, the top one's going to be solid circle when x is negative 4, and the bottom is going to be the open circle. So again, I'm going to come, let's say if x is less than or equal to negative 4. So if f of x is negative 4, it's going to be negative a half times negative 4 minus 6. And that's going to equal positive 2 minus 6 is minus 4. So if x is negative 4, y is negative 4. And I'll do one other point. Again, less than or equal to negative 4, so I'll say negative 5. Or negative 6. Let's do negative 6. So negative a half times negative 6 minus 6. A half of negative 6 is, or negative a half of negative 6 is going to be positive 3. 3 minus 6 is negative 3. So if x is negative 6, y is negative 3. So I'll come over to here, and at negative 4, I have a solid circle. And at negative 6, negative 3, a solid circle, and it goes that way. That's the left side of my graph. The right side of my graph now, I'm going to take the x plus 5. So I'll do f of, again, if x is negative 4, I'll plug it in. Negative 4 plus 5 equals 1. So negative 4, 1 is an ordered pair. And let's do 0. Because 0 is greater than negative 4. So 0 plus 5 is 5. So 0, 5 is another ordered pair. So at negative 4, 1, I have an open circle. And then at 0, 5, I have another one. And again, I draw my line through it. And so again, that's how I draw my piecewise functions. Some people do ordered pairs. I think it's just easy to plug in, especially when it's linear. 2 points make a, through any 2 points exists a line. I can clearly draw a line right through it. All right, so I come over to here. Now notice these are not as easy because while this is linear, this one's a quadratic. So this one's going to be a parabola, which can be a little harder to graph. This one here is linear. This one here is the quadratic, right? This thing. And then this is also a quadratic. So this one's going to be quite challenging to draw. This first one shouldn't be too tough. Okay, so I'm going to start again. I know my solid circle here. This one's going to be the open circle at these critical values, right? So let me just focus on the top one. So f of x equals 2 plus x. Now, if x is less than or equal to 2, I'm going to start with 2. 2 plus x equals 4. So when x is 2, y is 4. The next one I'll do is, that was f of 2, right? I'll do f of 0. So 2 plus 0 equals 2. So when x is 0, y is 2. So let me come and graph that. So again, let me just sort of identify my critical line I know is at 2. It's my little divider. And then I'm going to graph the top line, the 2 plus x line. If x is 2, y is 4. So there's my first dot right there at 2, 4. If x is 0, y is 2. That goes here. And so I see that when x is less than or equal to 2, this is the line of 2 plus x. And then I'll go to the other one, the bottom one, and that's my parabola part of it. And I have f of x equals x squared minus 2. So if x is, let's say 2, it's going to be 2 squared minus 2, which is going to be 4 minus 2, or 2. So 2, 2. Then let's do, if x is greater than 2, so let's go to 4. So f of 4 is going to equal, we got to go, quadratics go up and down very quickly. So instead of going to 4, let me just go to 3. So f of 3 equals 3 squared minus 2, which is going to be 9 minus 2 is 7. So when x is 3, y is 7. So let's graph that. So my first one, if x is 2, y is 2, and that's an open circle. So right there at 2, 2. And then 3, 7, which is way up here. And so I know it's going to be a quadratic, and so it's going to have a little curve to it. And that's my parabola part of it. Okay. All right. So then we keep going here to the next one. So that's pretty much all I have to do there. I mean, it doesn't have to be perfect, but pretty much, you know, the open circle, the closed circle, plot a couple points, and that's really all you can do. We come over to the last one and notice that it's 3 different functions. So we have some critical values here. It's kind of weird, right? We've got x is less than or equal to -1. Then we have x is between -1 and 1. And then we have where x is greater than 1. So this one has 3 critical parts, right? We've got the part, or 2. We've got the part, we've got 3 actually, where x is less than 1. We've got the part between -1 and 1. And then we have the part, so there's like 3 parts, part 1, part 2, and part 3. And each one of those sectors or pieces is going to have its own looking graph. So I'm going to start with the first one. I'm going to start with, this one's going to have a solid circle at -1. This one's going to have an open circle at 1. And this one's going to have open on this side and solid on this side. So it's going to be kind of weird. I'll show you. So let's go to the first one. F of x equals 2/3 x plus 1. So it says, if x is less than or equal to -1, this is the equation we're going to use. So I'm going to use some values that are super easy. I'm going to start, though, with -1, because that one's important. So 2/3 times -1 plus 1 is going to equal -2/3 plus 1, which is going to equal a positive 1/3. So -1 and 1/3. It's a terrible number. Okay, and then I'm going to do -3. Okay, because I think -3 is an easy number to work with here. So 2/3, times -3. plus 1. That's going to be negative 2 plus 1 is negative 1. So negative 3, negative 1. Okay, and I know that this is linear, so it's going to look like a line. So I'm going to start with negative 1, 1/3, which is about here, and it's a solid circle. And I'm going to get negative 3, negative 1, which is going to be about here. And that's the line for that. So that's the top one. I just drew that one. Then I go to the next one. The second one is a parabola. So the second function is a parabola. So it's going to be f of x equals x squared minus 1. And I'm going to do those borders. At negative 1, it's going to equal negative 1 squared minus 1, which is going to equal 0. So negative 1, 0 is one ordered pair. And then I'm going to do number 1. So I'll do 1, f of 1 equals 1 squared minus 1, which is also equal to 0. So 1, 0. And then I think I should do a number in between negative 1 and 1. So I'll do 0. So I'll do 0 squared minus 1, so it's negative 1. So in this little space here in the middle, I've got negative 1, 0, negative 1, 0, and that's going to be an open circle. So open circle here. And then I have 1, 0. That one's the closed circle. And I have 0, negative 1 here. So I have something that maybe looks like that. Okay? Because again, that's a parabola. So that's what the middle is going to look like. And then I'm going to go now to the last one, which is the last equation. I did that one. The last equation is 3 minus x squared. So f of x equals, and it's for all values greater than 1. So I'll start with 1, and that's also a parabola there, notice. 3 minus 1 squared, which is 3 minus 1, so it's 2. So again, when x is 1, y is 2. And then I'll do, since it's greater than that, I'll do like 3. F of 3 equals 3 minus 3 squared. And that's going to be 3 minus 9, or, 3 minus 9, so minus 6. So 3 minus 6. And so I come over to here, and I do, and it's going to be open circle at the 1. So when x is 1, y is 2, open circle here. And then when x is 3, y is negative 6. And so my parabola looking thing is going to go that way. Again, I know it's a quadratic, so it's going to have some kind of curve to it in one direction or another piece of it. And so that's what my graph should look like. Again, it's difficult, I get it, but what you're wanting to do is you're wanting to always use this value, whether you use it and do a solid circle there or you do an open circle there, but you want to use it because you want to have the beginning of your graph on that value. So every graph you do, you want it to start at that at those sectors, open circle or closed circle. You're never going to have two closed on the same line. You're never going to have two open. One's always going to be open, one's going to be closed. And this is it. Again, if you're familiar with your shapes, this becomes much simpler.